So what we're looking at here is cloning, genetic modification and breeding. Right, the first question on this sheet, we'll ignore that it's about digestion in the liver, but right, what we're going to do is we're going to look at this. There's a shortage of people willing to donate their organs. Scientists hope to create cloned organisms to solve this. What is a cloned organism? An organism that is genetically identical. Identical to another organ or from its parent. Right. State two advantages. Right. The first one is they are genetically identical. Right. So there's going to be, oh well, won't say no chance, less chance of the patient or the body rejecting the organ. Now, when you transplant an organ, the body thinks something foreign is coming, so it starts attacking it. So you have to give drugs to suppress the immune system. Right. What are the advantages there? There will be lots of supply of organs. So there is no waiting list. Some patients die because they're on a waiting list. Right, and then there's no I won't say ethical issues, no issues with relatives, where one person says no, he didn't want to donate it, the other one says yeah, but he said he wanted to donate it. So there's no issue, so you can pick any one of these. Right. Ooh, okay, there's a tiger. It looks angry. Siberian tiger. Right, so they are very rare and in danger of becoming extinct. So is a student who is motivated. That's very rare. Then we have to clone him. Right, a nucleus taken from a body cell. Remember, there's two types of cell. There's the body cell and the sex cell. They call this the somata, and what do they call this? Gamete. The gametes are made in an organ called the gonads. You'll come across all this. Right, a nucleus is taken from the body cell of an adult Siberian tiger. The nucleus is put into an enucleated egg. Right. Let's finish this and then I'll go through something. The cell is given a mild electric shock to help it divide by a cell division called mitosis. Right, a ball of cells is produced called an embryo. The ball of cells is placed into a uterus or womb of a female Bengal tiger. This female tiger is called the surrogate mother. Right, I just want to go through something. get a bit of room there. So I just want to go through this idea. Look, cloning of mammals or animals. So you've got the example that they go through in the book is this. You've got here the parent sheep. And the parent's going to donate the genetic material in the form of a, just say a body cell, a somata cell, right? So he's going to donate a few cells, and then whichever one is successful, it will, right? So that's the nucleus. But let's get this right. So we're going to call this the mammary gland. No, double M. Mammary. It's a mammary cell from the mammary gland. That contains the full, let's cheat and just say it's 46 chromosomes. Right, I don't know whether that's the case, but we'll assume that it's the same for sheep and humans. Right, so what's happened is the parent cell, which was called Dolly, donated a mammary gland cell. Now, you've got another sheep, which is going to donate the larger egg cell. So this here is the donor. It donates the egg donor sheep. That's the parent sheep. Now what we do with this is we take out the nucleus, we enucleate, we remove the nucleus. Right, so what you have after that, you have this cell with no genetic material because that's been removed. Then what you do is you get this cell, and because it's smaller, you inject it or transfer it into there. So now you've got all the genetic material from Dolly the sheep and none from the egg donor sheep. So now it's got nothing to do with this in terms of genetics. Right, what the next step is, you apply a little electric shock. That then starts dividing by mitosis. So these are now cells. So what you've got is you've got an embryo forming, embryo, and then as it develops, you then transfer it to a female sheep into the, so this is the it's a surrogate mother. Okay, so you transfer the embryo into there, and then when the baby's born, it will be the baby lamb here. It will be genetically identical to Dolly, its parent. It won't be to the surrogate mother nor the donor sheep. So that's what happens. Those are the things. So they've just gone through this here, and you have to learn that. Yeah. So let me just go over it once more. You've got the parent sheep, which donates the genetic material through mammary glands or a body cell, which has got the full set of chromosomes. You've got another sheep which donates the egg. You remove the genetic material, you enucleate it. You then fuse these two together. So now this egg cell contains the genetic material from Dolly the sheep. You apply a little electric shock. It starts dividing by mitosis and develops into an embryo. Once that happens, you transfer it into a surrogate mother, and when it gives birth, this baby lamb or baby sheep is genetically identical to the original parent, to Dolly. Okay. Right. I think that's it. Right. So now we're looking at the name of the enzyme that coats. Right. The protein in its milk is a blood clotting substance called factor 9. Right. The process of genetic modification used to produce sheep involves use of 2 types of enzyme. Okay. The name of the enzyme to cut it is called restriction enzyme. Just learn that. They also call it endonuclease, but the one that joins it is DNA ligase enzyme. And the vector that they use is this circular bit of genetics is a plasmid, and it's from a bacterium. Right. What does the word transgenic mean? Right, let's have a look. Right, transgenic. Look, there's a clue in that. That'll be to do with genes. Trans is movement, really. So where you've got the genes or genetic material from one species transferred into another species. So it's about species. So where you transfer the genes from one species to another species. Right. Transgenic sheep can be reproduced by cloning. Suggest advantages for reproducing transgenic sheep by cloning. Right. First of all, they are not identical, genetically identical. That's one advantage. You can use them to produce, well, whatever you want, but in this case, it's a part of a bigger question to produce clotting agent or clotting protein. And what did they call it? They called it factor 9. Okay, you can produce lots of it. You can produce lots of it, lots of protein, which patients might need, so they don't have to wait for it. Produce lots of protein on a mass scale. Right, okay. You can also, if you clone sheep, you can have more sheep and quickly, yeah. And also, once you've got a genetically suitable sheep, you don't have to keep reproducing it. So you only have to genetically, right, let's write it for genetically modify the sheep once. Name the small structures in plasma that are involved in blood clotting. Blood clotting. Okay, well, we don't really need to answer this, but it's platelets. Why is it important to have blood that clots? It stops people or patients bleeding to death. Also, it stops pathogens entering and causing disease. Well, causing infection or disease. Infection or disease. Okay, right, we just did this. So what you do is you get a mammary or any body cell, mammary gland cell. The important thing is a body cell because it contains the full 46 chromosomes, full set of chromosomes. I'm going to use 46 because I'll just assume it's easy to talk about full and half. I get a mammary gland cell from parent sheep. What do you do next? You get an egg cell from an egg donor sheep. What do you do next? You remove the nucleus from egg cell. The word is enucleate. Now, once you've done that, you fuse the the donor cell into the genetic donor cell into the enucleated egg cell. Apply a small amount of electricity. So apply electric shock. The cell will start dividing. The cell will start dividing in to an embryo. Once it's done that, you transplant or transfer the embryo into a surrogate mother sheep. Let's just talk about sheep. The baby born, the offspring, the baby born will be genetically identical to the parent donor sheep. In this case, it was Dolly, wasn't it? Right, so let me just go over that again. So you get a mammary gland from a cell, that's got the genetic material. You get an egg cell from an egg donor sheep. You remove the nucleus from the cell. You then fuse the two cells together, and then you apply an electric shock. When it starts dividing by mitosis, let's write that down actually. Dividing by mitosis. You'll start dividing, and then you transplant it into the surrogate mother sheep, and the baby will be born, and it will be genetically identical to the parent sheep. Okay. There you go. Let's have a look. Yeah, that's what we've just described. The table lists 3 events that take place in the cloning process that produced Dolly the sheep. Complete the table by giving the number of stages when each event took place. Cell division to produce, right, cell division happens here. That's 6. An embryo is put into the surrogate mother. So this is the embryo, and it's transplanted into the surrogate mother, so stage 7. An egg is collected from a female sheep. Right, so that's the parent, that's Dolly, and the egg is collected and it's there. That'd be 3. Okay. So which sheep in the diagram is Dolly? That is which sheep is it? Which sheep in the diagram is Dolly? Donor nucleus. Ooh. Let's have a look. No, that donated cell division, embryo. Yeah, okay, that's fair enough. Right. Did I say that wrong? Whoa, I think that there, let me get this right. That there is donating an egg. That is donating an egg. So that there is an egg. So that is the egg donor sheep. So this must be Dolly, because it donates the, yeah, there you go, nucleus. It donates the genetic, this bit here is the genetic material. Okay, that's fair enough. So Dolly is, no, I keep, Right. Let me get this right. The name of this sheep that was genetically identical is called Dolly. I keep calling the mum Dolly. That is not Dolly. That is Dolly. Okay, my apologies. I need to. Right, that is Dolly. That produced, yeah, there. It produced Dolly. Dolly is the final product. So let's get this right. It is that one. Which sheep are identical? Oh, right, okay. It was this one, Dolly, and it's there. That's its parent sheep, mother sheep. So P and R. P and R, so it's this one. Right. Sorry about that. That was a bit. Okay. That's for that. Okay, this is just a graph. This is just a simple, straightforward graph. Right, I won't. Yeah, that's a maths question. I'm not worried about that. Right, okay. Some people in the survey did not know anything about cloning. The process had to be described to them before they made a decision. Describe the process of cloning. So exactly what we've just done. Right, I'm going to quickly go over it. So you get genetic material donated by parent sheep, a mammary gland cell or body cell is donated, right? An egg cell is donated by another sheep and enucleated. So you remove the nucleus. The two cells are fused and an electric shock is applied. Electric shock is applied, and then what happens? The cell divides by mitosis and becomes an embryo. The embryo is transplanted into the surrogate mother sheep. The baby born is genetically identical to the parent. Okay, there you go. Genetically modified organism, right? An organism that contains genetic material from An organism that contains genetic material from another species. So you have to use this word. And yeah, genetic material. What are the benefits of cloning? So again, it's only a 2 marker. So you say you can this one's always a good one, genetically identical, and you can produce lots of new organisms quickly. Once you've got the organism, there's no need to genetically modify. No need to genetically modify organisms each time. And you can also produce or harvest useful substances. So the one that we know is the human growth hormone. Insulin can be done this way, and if you had your human growth hormone and clotting, no, blood clotting hormone, so you can produce useful products. Right. Whoa. Let's have a look. Suggest 2 precautions. Right, okay. Scientists have discovered a great deal of information about genetics by studying simple organisms such as bacteria. Suggest 2 precautions scientists should make to make sure that they can grow bacteria safely in the lab. Right, safety. Use masks and gloves. So that's safety equipment. Make sure you use sterile equipment. You can also use bacteria that are not dangerous to humans, that are not pathogenic to humans. Okay. Okay, this is exactly the same. What else is there? This is exactly the same. So how would you do this? It's like Dolly the sheep. So what's the first thing? You obtain nucleus from a body cell from parent dog or organism. Then you obtain an egg cell and remove nucleus. Once you've done that, you fuse together and apply electric shock. That will start the process of cell division. The cell will divide by mitosis and become, what does it become? An embryo. Right, once you've done that, transfer or transplant the embryo, into, where do you transplant the embryo? Into a surrogate mother. And then the baby born, or baby organism, baby born, is genetically identical to its parent. Okay. Pet owners can now have their dogs cloned. However, if a pet dies, then skin cells used to clone have been, however it's died, suggests why using skin cells from a dead dog may be less successful. Okay, because cells are dead. Because cells are dead, that doesn't make sense. It's not as if they've started rotting away. So if you maybe, okay, what they're saying is take some take some sample cells whilst the dog's alive. Cells are dead, so it's not gonna, they're no longer respiring. Okay, so just why a clone dog might not behave. Right. This is, I don't know, what's this to do with? So what they're saying is behavior is due to genetics and also the environment. It's not only genetics. I think that's it. I think that was the last question. Right, okay. We managed to get through that. That's quite a big video, but that should do it.